one online.
А вот это принес
Will
десятый,
start.
там зачет просто или как?
Я точно не помню. Как его убить?
Ну, ей что не нравится, то, что мне пропуски были вначале. Она там плюсом зачет поставила, с меня рекорд. Где она состояние вышло? Я не знаю, типа, во сколько нужно стараться, чтобы... Просто как бы если там зачет, то можно не стараться. Если там оценка, ну...
О, блин, надо было индикатор. Здесь кнопка сломана. Какой был кубик? Это еще ранний. Нет, процессор у него уже новая.
Столом можно подключиться?
Может, там есть одна свободная розетка. Даже есть напряжение. Okay, what I see time to start. Okay, let's start. Today I'm declaring MS auxiliary service. Need to explain what's auxiliary, what we are talking about. Maybe I will appear here. See? Nice device from the 80s. It was a fault locator. Some may still in service. It's a good to show structural idea of it's a device with minimal very slim device without extenders. So I can open it. The first unit, brains. This is CPU, program memory, RAM, and one more. What's this part? So, I have, how to say, mass core. It's central processing unit with plus RAM plus program. Program memory, where the program is stored. Now it can be one chip in this time it was loaded. But there is one more. What is one more? First, it's a power watchdog. U. It's a function U supply below U minimum. It has, so this thing should be powered by, it should obtain power from somewhere. Yeah? Hey, come here. This part, it's a power supply unit. PSU, power supply unit. Net power. It may be AC, yeah, it may be AC, but most probably it will be DC power from the substation battery. Power supply unit supplies all this with required voltage. 3.3, 5, some system require 12 volts, and one more it will be. But power, we need to be sure that our system operates correctly. For so, from power supply unit, voltage is taken to special watchdog, controlling what power is okay. If power is not okay, it produces two signals. One is a reset prohibiting operation. Without good power, system should not operate because it can operate falsely. And second one signal, it's done actually from power supply. There is a watchdog-like special relay with normally closed contacts. It produces signal fail. If there is no power, contacts will be closed and fail signal emerge. Watchdog disables this relay in case we don't have adequate power. Quite complicated power supply, isn't it? One unit. But there is pair of chip. What's one? Another chip. Not power watchdog, but general watchdog. It is possible, but due to disturbances, I don't know, due to power failure and so on, our program will hang. It will start somewhere in infinite loop or something like this can happen. Devices like this are equipped, it's mandatory, with a watchdog circuit. What it is? It's a timer. From CPU, there is a program code periodically sending a reset signal to this timer. If timer, it's in our case, it's external, absolutely independent timer. If timer do not receive the signal within circle time, here, if I remember correctly, if signal do not appear within 2 milliseconds, timer will produce reset signal, hardware reset signal. CPU will receive hard reset, all devices will receive hard reset if test signal heartbeat. Many designers call it heartbeat. So if heartbeat signal do not receive within 2 milliseconds of cycle time plus delay for timer operation, hard reset signal is produced. I can draw it in red. So this one, power control. Watchdog. Okay. Who draws hearts like this? Heart. Heart pulse. Inside a program code, special part is planted, so within cycle, signal sent to reset watchdog timer. If signal do not arrive, system will get hard reset. Good practice is to have indication what hard reset occurred. Good practice. Okay. Power supply. We'll speak later. Now, who remembers this kind of indicator? Now they are hunted. It's from, actually it's taken from a calculator. What's this? It's a very basic HMI. HMI. What is H? H is for human, M for machine, and I is for interface. This one had only, now it has only one button, I don't know when one broke, I need to find a replacement. So, this HMI part, very simple indicator, something to tell to human. When device operates, at last you need one LED operate. Put one green LED is okay, one red not okay. Better have some verbal indication, but not always. Expensive display with so mnemonics is required. It's more marketing because most of the time your device is watched by no one. What HMI should produce? Operate, not operate, and essential information. This device was a fault locator. It operates in case of line fault. It had two important strings. One, I'm okay. Second, fault occurred. And distance to fault. If we speak about fault location, fault protection devices, there will be, if in case this device operates, there will be kind of rush. Personnel will be under pressure. We have line disconnected, we have clients disconnected. Make operation as easy as possible. Also, it had two relays. To send armed binary signals. This device do not disconnect anything. It just indicates fault. Anyway, it has binary signal. I don't know what my customer may think about automation. But if I produce one signal, I'm okay, they always can attach it to some kind of alarm, something not okay. It's for customer. And second one, I have something to tell. Binary signal, device operated. This means, please, take attention. I have something for you. This one, what had fault distance? And both octocouples. Old nice octocouples. For what? For serial line communication. Device send out date. This one was able to send via serial communication fault distance, faulted phase. Binary signal. It is easiest way to get info into any information system if you have simple binary signal unoperated. Then some kind of protocol pooling protocol can be activated to extract data from your device. So it's very basic rudiment HMI. Modern, of course, today nice displays are available. On nice display you can have set of menus, you can have nice diagram. In reality, most of the time they watch them. But they are very good in marketing, as a marketing. Anyway, customer pays for it. Okay, what's next? I need to pull this out. And here I have something interesting. First, this section. 1, 2, 3, 4, 5, 6 operation amplifiers with same circuit of capacitors and resistors around it. What they are? What this part is for? Similar operation amplifiers with capacitors and resistors. Binary faster to send signal. No, it's not binary faster to send signal. You may have serial communication can be faster. What's the trick with binary signal? It's very easy to integrate. And you starting from SCADA system, when you use one of the binary inputs of your RTU, multiple. No, not multiple. Question: if your device provides binary, simple voltage multiplier. No. Voltage has nothing to do it. Easiest thing, so-called dry contact. Starting from simple indicator, customer may want to, I don't know, they can hire dumb personnel, someone just watcher. Or simple indication, ring and lamp. The binary signal can be easily put into SCADA system. Binary signal can be taken by some kind of monitor. For customer, it's very easy to integrate binary signal into their data acquisition system, some kind of signaling system. It's good for customer. Next step, first we indicate with binary what we have something to tell. Then via serial communication, via optical loop and so on, the customer data acquisition system can extract our information. But it's the easiest way to integrate our device into their architecture is with binary signal. That's why it's good for us. It's good for, for us to market our device is to provide auxiliary binary signal for customer. We have something to tell. Okay, coming back. this part. Operation amplifiers, capacitor resistors. What is this? Huh? Analog filters. It's an analog pre-processing part for device. Wait 1 second. 1, 2, 3, 4. Should be device. Have 1, 2, 3 voltage channels and 1, 2, 3, 4 current channels. One, two, three, 4. These are for currents and volt. More base. Analog filters, analog preprocessing part. These are low pass filters. Second filter, low pass filters to cut off. Not need frequency. 1, 2, 3, 4. This limit over voltage protection, limiting diodes. Multiplexer. This one had multiplexer. Analog to digital converter. Okay, it's fine. But what is this part? Analog part, ADC, data. Fine. But what is this part? When we look at our device, inside the logic of our device, do something if something. What is what's something in if? Disconnect line if current exceeds. For this device, start if current exceeds and calculate float distance. Yeah? What should device know? Limit of current. It should not calculate float in load regimes because load regimes are not fault. Yeah? Yeah. But where is border between this threshold line between fault and not fault should be programmed, yeah? Line parameters. Resistance of direct sequence, resistance of zero sequence. Active should be programmed somewhere, yeah? Device should know it. And here comes one of the important part of XLR. So HMI, DC, data communication, should be somewhere. But here, large part, I can mark it with giant S. What's S? S is for settings. We need to store constants. 1, 2, 3, many constants. Constants thresholds. What is fault, what is not fault? 1, parameters of our object, also line resistance, capacitance, maybe something more, and some service constant, like baud rate. What's your knowledge in serial communication? Yeah, you need baud rate. Somewhere should be programmed baud rate. Okay, USB don't need baud rate programmed. Device address, device IP address, and so on. So we have what we have. We need to store array of constants for our device or settings array. So this central processing core, one or multiple, high-rank devices do have what? Central logical unit and DSP, digital signal processing units for channels. All of this needs to be programmed. Also, timing, moment, many types of input converters require calibration. Calibration data should also be stored somewhere. This can be settings array. This one is a nice example of AT's technology. How can you store settings? Write on the paper. Old analog device stored the settings in position of levers attached to springs or attachment tabs from some transformers, variable resistors and so on. Here we deal with numerical devices. What's idea number one? Jumper box. Wait, another device. Here. Overcurrent relay. Two-stage overcurrent relay. What's the minimal amount of settings for two-stage overcurrent relay? You got this course of power system protection. What's minimal amount of settings? You have two-stage minimum. Let's assume what first stage is instant. Yeah? For instant stage, we need trip current. Correct? Correct. Second stage is delay. For second stage, we will need trip current and delay time. So minimal amount of setting for overcurrent relay is 3 analog digits, 3 digits. What do we see here? Here we have, see, the switch box time. You can select here 2 digits are available. 1/2, 1, 1.5, 1, 2, plus 1, 0, 0, 1, 0, 2, 0, 4. And time also. 1, 2, 3, 0, 1, 0, 2, 0, 3. Actually, for delayed stage 1, 2, 3, 4, jumper box, you plug in correct position. And for instant stage, 3 jumper box. What how to say, general note on settings? First, it should be easy to set, yeah? The harder to program setting, the more possibility what someone, the higher probability what someone will make mistake. It should be clear, it should be easy to do, but settings should be protected from unauthorized access. Understand why? That's why, for example, here, lid is sealed, here, screw, and here, two holes, you put a seal through them and crimp. How many seals did you saw on devices? It's a violation. Setting block should be sealed, and special record should be taken by security. In any case, seal is disturbed, we have someone to blame. In case of serious incident, unsealed setting block. In case of more advanced device, first, password or better certificate protection, encryption protection, and journal change in setting should be stored independently in NVRAM, and this journal should be available for forensic. In case of personal faults, we should know who to blame, not who to blame. There will be investigation. In case of serious incident, there will be an investigation of National Security Service. Unauthorized change in setting is a serious, potentially it's a serious crime. Okay, need to go forward. What else? I will return to settings. Now I'm there. There is a settings array. I will come back to settings. I will speak about that. What's lacking my structure? If it is a protection device, if it should send out power binary signal for switch, for high voltage circuit breaker to operate, current of 5 amps minimum is required. Block of output relays. Good, nice block of output relays. Simple, commercial grade. Come on, no. Simple commercial grade relays will not work here. Special measures should be taken. And what left here? What left from my device? How do you think? Oh, no. Spacers around. What are these? Oh, I have one. Transformer? Simple transformer? No, it's a current transformer. Okay? It's a special crafted current transformer. This part, 4 current inputs, with the, here on the base, the load resistors. This part converts current into proportional voltage. Here, voltage transformers, for another part, transformer. Also, here capacitors and coils. This is power filter. Input power filter. Problem what in substation on the one side. Your nice electronics device lives in one network which relays computation of simple time relay can produce surge up to 800 volts. I saw it in person. So this means what we need to care about protection of our power supply. Here at the input, anti-surge filter will be welcomed. Okay, what should I do? I should speak. I promise to speak about settings. This goes here. HMI. Sure, I'll need another HMI. Let's speak on attend or not attend. Okay, what I like. Maybe I'll explain my idea with overcurrent protection. Logic. You have, let's say, EA, EB, IC. What you do with them? Perform DFT, obtain phasors. You have phasors. Now you need an overcurrent protection. Let's say you have source, your line, adjustment line. What will be structure of your overcurrent protection? Here, fault number 1. Instant zone, let's say this is A, this is B, so this will be AI. What will be trip current for instant zone? Power system protection course. Length. This is time of operation. Trip current for this primary zone. will be roughly 1.1 multiplied by I of the first fold. Yeah, it's roughly. And precise. This is rough. Precisely, we need to program what? (1.1) multiplied by it's a safety. 1.1 is a safety factor. 10 for guarantee of non-operation due to non-precision. 10% safety margin. That's why 1.1 multiplied by I1, which is external fault max, and divided, we are programming in amps. What do we have in our signal wave? Current transformers. So, first stage operates if current is greater than this. What do we have here? This can be in programming code. It's not changed often. This one programs continuously from range, and this one ratio of current transformers came from the standard row. Current transformers are produced in standard row. You can have 100 to 5, 200 to 5, 1000, 1.5, 2000 to 5. This is actually, it's a selector. Should be selected from row, series. Selector like this one. Selector and continuous. Let's look for second one. What will be? This instant zone do not protect whole line. It's instant. It's simple. It is this one is with programmable time. Actually, it can here. It's programmable. In simplest way, first zone operates instantly, without delay. Instantly. Can protection operate absolutely instantly? What's your knowledge in power system protection? Lighting, surge arresters. You cannot operate absolutely instantly. Anyway, you need short delay, 50 milliseconds or 100 milliseconds. Why? Because you have surge arrestor, lighting protection on your line. In case you got lightning strike, surge arresters open, we need to give them time to operate. They will, they will absorb over voltage energy from lighting and they will disconnect. They should. Will is not a good word here. They should disconnect, forming arc by themselves. If within 100 milliseconds surge arresters do not restore the insulation, we disconnect line. That means what they failed. Possible. Old worn arresters, or maybe old series of surge arresters relied on a gas generating chamber. If this chamber is worn to the end, okay, it's a fault of line service. They should check them. If they failed, surge arrestor will simply open and we disconnect line. We have problem. What we have? Second one. This instant zone can protect whole line. B1. This is our A2 delayed zone. It should overlap. It should protect our line and overlap the next adjacent line. Maybe like this, I start drawing for schematic like this, or if we have rudiment protection, something like this, it should be selective, so there should be a time space between our protection and next line protection. In this case, what will be setting formula? In simplest rates, current will greater or element, so trip of any, activates delay, and this is our signal. Here, A phase current, B phase. Okay, simple logic for second stage. Simplified. This is simplified logic. In this simplified logic, what do we need? In this simplified logic, trip current is safety, Drošums in Latvian safety factor, multiplied, this can be schematic, it's one, it's not start factor, load startup current or load and rush current divided by transformer factors and one more factor of hysteresis. In case of instant zone, it returns when When line is disconnected, load is disconnected, current is 0. This zone coordinates, it's a backup for next line for next line protection. If next line protection operates, this should return. We should have current state of the binary signal. Trip current, or let's say on current, should be higher than off. This is required because first, current is not constant, it changes. Second, we always have a, how to say, jitter in one step of our analog to digital converter. To prevent situation, up, down, up, down, up, down, 1, 0, 1, 0, 1, 0, we need modern practices 4-5% hysteresis. One second. Be right back. 1 second. I will. I will say hello. It's a parallel meeting. I will just show. I'll be back in a minute.
work with also. How you solve that problem?
Attending a technician and electrician.
Ah.
Delegate and the supervisor. My areas are opposite. Is a manager and the supervisor.
So how you manage that problem? What was the solution for you?
Just they fill the form, I will fill the form. What can I do? And what are the numbers involved in that project? And then I want to translate that exactly into English.
Good.
Yeah.
Hello. Where is Professor Doditzer?
You went to meeting.
Ah, you have me. Yes.
Yeah.
No.
He told that he was going for a meeting
Meeting.
to see someone.
Ah, he is going to some meeting. Yes.
Yeah.
Ah, okay. Try to find.
Ah,
Yeah.
he was in his direction. So what is the again solution for it? How we can replace it or how we can do it?
Just checking the voltage and current before putting the plug.
Decrease the lamps.
Into ground supply. Yeah. And after that, after finishing all this one, I will maintain at the ground and the same place. The ground.
Ground.
Then we need to give the supply voltage. It's a normal point.
If they usually we don't
The radical, they are doing like that only.
we don't if there is any problem we don't ground it right for the practical thing. I know man, I'll ask you to go. Seriously.
All the people inside of Tamil and Sweden laws. Including in European Union, Sweden.
Sweden?
Yeah.
Bro, if you have knowledge, there are plenty of job options in Sweden.
If you go for your own work means, you know what can I do? Please before that. That's the reason I followed that, you know. You didn't reply the message. You reply means, what can I do means I will send it only for getting that done. Please indicate with any also.
If you have a connection, you will get
Yeah.
job very easily.
Advantage means you are doing nonsense in it's the main advantage.
That's it. You told me that we are doing the masters in this Baltic country, so we have a value only in this Baltic country. Comparing, yeah, but comparing to other countries.
It's okay, but rules is different. Like in the city.
That's my last point.
If you are doing in that course in Turiba means it's not valid.
I'm guaranteed that whoever passed out Purika, they will get a job in MBA. He will get the job somewhere in the management, maybe the business center, but he won't get the management. If you, especially for English, because no one put the English citizen at management. Even if you potential. key values of the Tatiana initial
Yeah. Two. Yeah.
No, what we can call this one? I forgot this name.
It's power supply circuit.
No, this resistor.
Totally it's power supply circuit.
It's a PCB board, right?
Yeah. PCB is power supply circuit.
Okay.
Normal power supply circuit. And this is indicator and capacitor and resistors.
You know how to design this one?
I know little bit,
It's very
but I know that
It's very
operation.
It's very complicated to
Yeah.
place this one, right? It's the main
But
problem.
it's
We cannot cross over it like this. To place this one is very difficult.
but it's easy. It's like if you print in the if you design it in the computer means you can easily print it on the PCB board.
Yeah. I tried during my bachelor's, but I was trying this one to place this one. It was very complicated.
If we give the wrong connection, it won't burst, I think.
Cross.
It's like, yeah. Solid.
You know, so
Yeah.
I tried that.
I did not purchase for my own.
good news, even have bad news. Good news and bad news. Oh no. Okay. I can cut this off.